All right, friends and neighbors, time now for another networking video. Last time we talked about everyday addressing. Today is not so everyday addressing, or are they not so everyday addressing? So previously, these were the addresses that we were talking about. Remember that this is binary, and so we've got prefix and suffix, and so if we break out our IP address into all binary, right? We get all zeros in the prefix or all zeros in the suffix, and we get this computer. And then we went down all of these, right? Network ID, all zeros in the host, all ones in the host. These are the network and broadcast addresses at that particular subnet. Here is the limited broadcast, all binary ones. Usually translates to 255, 255, 255, 255. And then we've got 127 and anything, and that's loopback. So these are our everyday addressing. And then, of course, we could add to that maybe our IP address. And what we looked at after we had this table, right, was the host routing table. And I put some stars over here next to the ones that we just talked about, right? Here's the 127, that's loopback. Here is a network address with all zeros in, if we did this in binary, it'd be all zeros. That's the network address. Here's all ones in the host portion. That makes it the directed broadcast at this particular network. And then there is the limited broadcast of all ones and all ones. All right, so those are the standard addresses. And then, of course, we would have the host address itself, an IP address right here in this case. Okay, there's multicast. And then here is a default gateway line, all zeros in the network destination and in the net mask. And those would constitute a fully functional IP routing table. And this is the addresses that we get from, our everyday addressing. But what about other IP addresses that we might see? And so sometimes we see a 169.254 something come up, and it turns out that that's a legit address. It comes to us from RFC 3927, Dynamic Configuration of IPv4 Link Local Addresses. And what we're trying to say here is that if you don't have a DHCP server, if you don't have other servers, you can automatically generate your own IP address. And so there's a particular range for this, right? 169.254.1.0 to 169.254.254.255. So you can generate anything inside there. Now, the RFC says you've got to expect that you might have collisions. So we ARP for this, or we do a gratuitous ARP, right? So just like when we talked about ARPing for your own IP address, you would ARP for this one also to make sure nobody else has it. Now, this is usually for local communication only, which means we don't route these. We don't have DNS pointing to addresses that have 169 as their resolution. You don't want to use static 169s because that'll get you into trouble with your DHCP server. But there you have it. It's very common to see 169.254 pop up. And in fact, there was an update to this particular RFC or to the verbiage in 2020. So it's not just an Apple or a Microsoft thing. It is absolutely a legit set of addresses that comes up. So if you see them, now you know. Now, what if you saw one that looks like the default gateway line? So here's an IP packet. You can see it right there, but I've highlighted it in red down here. This is a host using 0.0.0.0 as a source IP address. And we can see that in this packet, it's used in conjunction with DHCP. So what is this all about? Well, it turns out that this is what we call the DHCP DORA process. So DORA is an acronym for Discover, Offer, Request, and Acknowledge. At the beginning part, when you first come up on a network, you don't have an IP address. So how do you ask for an IP address when you don't have an IP address when you're communicating on an IP-based network? And the answer is that we use this specialized address for hosts. So hosts that are trying to find an IP address all use this particular address. But of course, in DHCP, the IP address is tied to your MAC address as well. So 0.0.0.0 means this host, whatever host you're sitting on. This is definitely not a default gateway line. It looks very similar, but it's not the same. One is a routing table entry, and one is an IP address that you see in an IP packet. Well, what about other addresses that we might see? Well, every once in a while you'll pull an address from these address spaces down below. It's extraordinarily common to see 192.168 something, right? .0, .1, whatever it is. And those are private addresses. RFC 1918 specifies these particular ranges, one in Class A, one in Class B, one in Class C, for use in private internets. Well, what in the world is a private internet? Well, as we know, decades ago, we knew that the IPv4 address space was running out. And in fact, it did about 10 years ago. And so what to do about that? You can't get new IP addresses anymore. So a device called a network address translator was envisioned. That's RFC 3022. So RFC 1918 addresses are used in conjunction with a network address translator or network address translation for the purpose of conserving IP addresses. And so whenever you have a NAT box, you have a private address. And if we view this the other way around, whenever you get one of these, you know that there's a network address translator between you and the internet. We'll talk about NAT later on. So the whole purpose was to conserve addresses and to make non-global or private addresses communicate with the internet. So this is back to another routing table, and here I've just circled the private addressing part. So every address, or I should say every network, is going to have really three addresses that a host is concerned with. Whatever my network is, whatever my broadcast address is, and then whatever my IP address is. So those three will go with any network that you're sitting on. This one just happens to be private. But there you go. That's why you see in so many homes and apartments and everything else where somebody's got a wireless home gateway, that thing is running NAT, and that's why we get private addresses. We talked about everyday addresses, so these here they seem unusual, but they're actually kind of everyday as well. And if we think about the classful address spaces, Class A, 0 to 127, Class B, 128 to 191, and Class C, 192 to 223, we're actually carving out addresses from each one of those spaces. And we're still talking about classful addressing here. But it gets even better. You just wait until we're actually classless. And then we'll have some real fun with subnetting and supernetting and aggregation and all of that. All right, well, I think that'll do it for this one. Like and subscribe if I helped. And hey, may those packets always reach their destination, whether you're using everyday or not so everyday addressing.